Because you're working on a group project for senior design, you're all going to learn about project management. So I thought it would be a good idea to explain about project management and in particular what you need to do for this course. Project management includes planning, scheduling, and controlling. Planning means you set goals for a project, define the tasks, and organize your team around available skills and disciplines. You create time to market and component cost estimates, develop a project budget, which in your case is a maximum of $280 per student, and define your estimate of person hours to develop the product. Scheduling means you relate the number of people and length of tasks to specific lead times to complete a project. The three time-honored methods are CPM, Critical Path Management, PERT, Program Evaluation and Review Technique, and formulation of Gantt charts. Creating Gantt charts is by far the simplest scheduling method to understand, so we will have you learn to create a Gantt chart for your senior design project. Controlling can only occur after you have planned and scheduled a project. In controlling, you track your component cost, budget, and schedule relative to what you planned to make sure you're moving the project forward. If necessary, you revise your plans when you hit a roadblock. For our class, you will document your project plans and schedules in your project reports. A project manager directs activities of the team so that the project gets done correctly, on time, and on budget. This person is usually the most organized one around. He or she provides coaching to the project team in working efficiently. My advice is to have a discussion within your team and appoint your most organized person to be your project manager. Here is a screenshot of the format for a Gantt chart. I placed a copy of the Excel spreadsheet in the item Template Documents. In a Gantt chart, you show all the tasks you need to complete a project, with the start date being the first green-colored box in a particular row, and the end date being the last green-colored box in a row. The tasks are defined in the rows, and the dates are defined in the columns. In this chart, I put days in the columns. You can change that to weeks or months if more convenient. For example, given that your project will run from September to May, you could show 33 weeks worth of columns. There are two types of tasks as shown on the chart. The ones in green with a solid line border around them are called critical project tasks. These are the most time-sensitive tasks. If you don't complete them on time, the entire project will be delayed. Examples of critical path tasks include writing the PDS, creating design concepts, doing component drawings that take a long time to fabricate, buying parts that take 2 to 4 weeks to arrive, assembling your prototype, and testing it. The tasks colored in green but without a border around them are non-critical. These tasks could be delayed and your project will still get done on time. To illustrate that fact, we place yellow squares in front of the green ones to define the slack time. This means that you could purposely start the non-critical tasks late by the amount of days colored yellow and still complete the overall project on time. Examples of non-critical tasks are creating final assembly drawings for illustrative purposes only, or buying parts that arrive in a day or two. Codes and standards are long, legalistic style documents that define the technical design details behind most products. They tend to be organized around traditional engineering disciplines: mechanical, civil, electrical, chemical, and software engineering. Industrial organizations such as IEEE, ASME, SME, and ANSI have their engineers write and maintain these documents and publish them on their website. They're supposed to be nonprofit organizations, but they charge surprisingly high prices to download their documents. Every technical field that I know of has codes and standards, but for this class, I will discuss only ones relevant to mechanical engineers. Your task as you develop your designs will be to document which mechanical engineering standards govern the details of your design work. Due to the high cost of buying the standards, you will not need to download and pay for them, We simply ask that you read the summary of the standards published for free on the relevant websites. We still need to see correlation between your drawings and schematics and the actual standard numbers. You document that correlation in your project reports. Codes and standards are used in power generation, building heating, fluid flow, and transport vehicles such as autos, elevators, and construction equipment. For example, the field of metrology could not exist without standards generated by ANSI. Codes and standards agencies were founded over a century ago in response to major and sometimes catastrophic accidents with people using early industrial equipment. Due to the widespread occurrence of factory fires in the first few decades of the 20th century, standards were created for electrical safety and fuel burning. They were also created for specific products where safety and operational efficiency were paramount to building an industrial infrastructure. Today, the agencies publish and charge high prices for large numbers of documents that govern every detail of a product design. They have numerous committees of design and safety engineers who make minor tweaks to standards and occasionally write a new one. The committees include industry experts at companies that manufacture relevant products. When you work in industry, your company can afford to purchase the standards. The design engineers are expected to read the fine print of the standards to understand how to design the covered products. The American National Standards Institute, ANSI for short, was founded to create and promote all types of norms and standards in industry. Today, ANSI harmonizes their documents with the International Standards Organization, ISO for short. ANSI and ISO standards are found in quality control, medical devices, environmental management, and in IT. The American Society of Mechanical Engineers, that's ASME, was founded in 1880 at the dawn of time for our profession. Probably a bunch of guys sitting around smoking cigars and talking about hammers and nails. Today, ASME codes govern every mechanical product you can think of. For your projects, the best way to figure out which ASME code governs your project is to go to www.asme.org and do keyword searches with the same keywords you use to do a patent search. Note the prices for their standards on the right side of the page. If you bought 4 of their standards, you would quickly exhaust your project budget for the year. ASTM International was founded in 1898. It used to be called the American Society for Testing in Materials. It is best known as the organization that tests metals and plastics for their material properties. Without their test data, nobody could design a product. People couldn't publish engineering textbooks, and you couldn't get through many of the core mechanical engineering classes here at Stony Brook. I suppose that also means I would be out of a job. Good thing ASTM does exist. ASTM has over 12,000 standards, a clue towards how many types of materials exist in the world. For this class, your job is to find the ASTM standard numbers that govern the raw material you use in your design. This could be different grades of steel or aluminum or types of plastic that you select. Underwriters Lab, UL for short, is best known for their fire safety standards for electrical equipment and consumer products. Most electrical products you buy will have the UL logo stamped on them. High voltage electrical products are virtually unsellable unless the manufacturers design them to the UL standards and present samples to the UL labs for testing. For projects in this class that have an electrical component, go to the UL website and see if you can find the number of the UL standard that governs the general design of the product. Again, use your keyword search. The boxes on the left side of this slide show the UL standards numbers that govern categories of products. For example, UL 508A governs the design of industrial control panels. This concludes our series of online lectures for MEC440. Good luck with your projects, and your professors will see you in class.